The ozone layer is a vital component of our atmosphere, protecting us from the harmful effects of the sun's ultraviolet radiation. In this video, we will explore the chemistry behind the ozone layer, how it is formed, and why it is important. The ozone layer is a thin layer of gas that surrounds the Earth, located in the stratosphere, approximately 10 to 50 kilometers above the Earth's surface. It is made up of ozone molecules, which are composed of 3 oxygen atoms. Ozone is formed through a process called photodissociation, which occurs when ultraviolet radiation from the sun breaks apart oxygen molecules in the atmosphere. The resulting oxygen atoms then react with other oxygen molecules to form ozone. The ozone layer is constantly being formed and destroyed through a process known as the ozone-oxygen cycle. In this cycle, ozone molecules absorb ultraviolet radiation, breaking apart into oxygen molecules and free oxygen atoms. The free oxygen atoms then react with other oxygen molecules to form new ozone molecules. The ozone layer is important because it acts as a shield, protecting us from the harmful effects of the sun's ultraviolet radiation. Ultraviolet radiation can cause skin cancer, cataracts, and other health problems in humans, as well as damage crops and other vegetation. However, the ozone layer is also vulnerable to damage from human activities. Chlorofluorocarbons CFCs, which were commonly used in refrigerants, aerosol sprays, and other products, were found to be destroying the ozone layer. When CFC are released into the atmosphere, they break down into chlorine atoms, which then react with ozone molecules, breaking them apart and reducing the amount of ozone in the atmosphere. In the next segment, we will explore the impact of CFC on the ozone layer and the efforts that have been made to protect it. In the previous segment, we discussed the chemistry behind the ozone layer and its importance in protecting us from the harmful effects of the sun's ultraviolet radiation. In this segment, we will explore the impact of chlorofluorocarbons CFC on the ozone layer and the efforts that have been made to protect it. CFC were first introduced in the 1930s and were widely used in refrigerants, aerosol sprays, and other products. However, in the 1970s, scientists discovered that CFC were destroying the ozone layer. When CFC are released into the atmosphere, they rise to the stratosphere, where they are broken down by ultraviolet radiation, releasing chlorine atoms. Chlorine atoms then react with ozone molecules, breaking them apart and reducing the amount of ozone in the atmosphere. This process is known as ozone depletion. Ozone depletion leads to an increase in the amount of ultraviolet radiation that reaches the Earth's surface, which can cause skin cancer, cataracts, and other health problems in humans, as well as damaged crops and other vegetation. In response to the discovery of the harmful effects of CFC on the ozone layer, the international community came together to address the issue. In 1987, the Montreal Protocol was signed, which called for the phasing out of the production and consumption of CFC and other ozone-depleting substances. Since the implementation of the Montreal Protocol, the production and consumption of CFC and other ozone-depleting substances have been significantly reduced. As a result, the ozone layer is expected to recover by the middle of the 21st century. However, there are still challenges to be addressed. Some countries continue to produce and use ozone-depleting substances, and there are concerns about the impact of climate change on the recovery of the ozone layer. In the next segment, we will explore the current state of the ozone layer and the ongoing efforts to protect it. In the previous segment, we discussed the impact of chlorofluorocarbons CFC on the ozone layer and the efforts that have been made to protect it. In this segment, we will explore the current state of the ozone layer and the ongoing efforts to protect it. Thanks to the Montreal Protocol and other international agreements, the production and consumption of ozone-depleting substances have been significantly reduced. As a result, the ozone layer is showing signs of recovery. However, it will take several decades for the ozone layer to fully recover. In recent years, there have been some concerns about the impact of climate change on the recovery of the ozone layer. Climate change can affect the ozone layer in several ways. For example, changes in atmospheric circulation patterns can affect the distribution of ozone-depleting substances and their breakdown products. In addition, some chemicals that are used as replacements for ozone-depleting substances, such as hydrofluorocarbons (HFCs), are potent greenhouse gases. HFC do not deplete the ozone layer, but they contribute to climate change. To address these concerns, the international community has been working to phase out the use of HFC and other potent greenhouse gases. In 2016, the Kigali Amendment to the Montreal Protocol was adopted, which calls for the phase-down of the production and consumption of HFCs. The Kigali Amendment is expected to have a significant impact on reducing greenhouse gas emissions and slowing the rate of climate change. It is also expected to have a positive impact on the recovery of the ozone layer. In addition to international agreements, there are also ongoing efforts to monitor the state of the ozone layer and to protect it from further damage. For example, the World Meteorological Organization and other organizations regularly monitor the ozone layer using satellites and other instruments. Overall, while there are still challenges to be addressed, the international community has made significant progress in protecting the ozone layer. With continued efforts, we can ensure that the ozone layer continues to recover and that we are protected from the harmful effects of the sun's ultraviolet radiation.